All right, so what I want to look at is these bottom two, and these two are similar to what we saw on the bottom two on your homework last night. So basically we have a spot in the expression here where we've got the distributive property, where we've got something being multiplied by those parentheses, but then we've got this additional term that isn't part of the distributive property. So what we're going to do to simplify these, or to make them kind of easier to solve, is we're going to start still by doing the distributive property. So we're going to distribute in this one the 7 to both terms, and we're going to have 7 times 7n plus 7 times 4. So when we distribute there, what do we end up with? 7 times 7n, Geo, is 49n plus what's 7 times 4? Lucas? 28. We had that plus 8 out front that we haven't done anything with yet, so we're just going to bring it down. Now when we look at this, we've got it distributed and we've got that plus 8 out front. We're going to just look at, we've got 3 terms. Are any of those like terms? And if so, which terms are they that we can combine, Calvin?
8 and 28.
Yeah, so at this point, all we want to do is combine like terms. So we're going to have 8 plus 28 is 36. And then that 49n is just going to bring down because there's nothing to combine it with. So basically, all we're doing is taking this longer expression, simplifying it and saying that's the same thing as 49n plus 36. And when we go to solve that expression, 49n plus 36, is going to be a lot simpler to work with than our original 8 plus 7 times 7n plus 4. Do you get what? Do we understand that those are the same? Yes, Hank? Yeah. Questions on that? One thing I will say is there were some people that asked last period, so how I told you that this kind of first line of work with the distributive property you can skip and do in your head, I'm still fine with that. You don't need to have this line of work, but what I don't want you to do is I don't want you to go from the original expression all the way down to this final answer and try to do the distributive property and combining like terms in your head in one step. I want you to show here's what it is distributed and then combine like terms. Reason being is right now these are more of the basic where there's not that many terms to work with. They're going to get more complex over time, and when you try to do too many steps at once and try to do too many steps at once in your head in particular, that's when you start making some really simple mistakes, some mathematical errors because you're not looking at the numbers close enough. So do the distributive. If anything, you need to have this line of work and then your final answer. Okay? All right, let's look at this other one, and then you're going to practice some of this on your own. So distributive right here again, we're going to pass the 2 out to both terms. So we're going to have 2 times 8x plus 2 times 4. What does that simplify into? When we distribute there, what does that simplify into? Henson?
16x and plus 8.
Good. 16x plus 8, and I'm going to bring down the plus 5. Now looking at that, which terms, Avery, can we combine?
5 and 8.
Yeah, 5 and 8 are both constants. What'd you say? 13. So we're going to have 16x plus 13. You might have been thinking of it as 13 plus 16x, which is fine too. The proper way of writing it is to write your constant last and your variable terms first. It's really getting tricky to open these days. But 16x plus 13 is correct. Good. Questions on that? So again, this 16x plus 13, this expression, and this original expression are equivalent. If we were to solve both of those, if I said x equals 10 and you solved the top one and you solved the bottom one, you would get the same answers. But by distributing and combining like terms, we make it a lot simpler for when it's time to solve it. It's a much more basic expression to solve, which is why we do this. Okay? So if you look at the back of your homework from last night, there are 10 questions on there. Some of them have this where it's the distributive property and combining like terms. Others are just combining like terms, so simplifying expressions. We're going to take about 4 or 5 minutes here. We're not going to move around and work with people. If you want to talk with the people around you, that's fine. But see if you can do these 10 questions, and then we'll go over answers together before we move on. Okay? All right, we're just going to real quickly look at 2 things, writing equations and then solving with substitution. And like I told you earlier, when we solve with substitution, that's not how we're going to typically solve our equations. So it's not going to be a big, heavy focus on topic 9, but we are going to look at it. But we're going to start by writing equations, which this is going to be a quick review because really we already did this skill with expressions. The only thing that's different is instead of writing expressions, now we're writing equations. So what I added, do you remember the day, it was probably 2 weeks ago now, that we spent time brainstorming all of like the buzzwords for addition and subtraction and multiplication?
Yeah.
So sum is addition, product is multiplication. Do we remember doing that? So same thing that we need to use here, except this time now I added this list off to the side. These are all buzzwords or phrases for the equal sign. So is the same as much as, is identical to, is equal to, gives, and equals. So when we see those are words or phrases that say, hey, we're going to put an equal sign in this. Okay, so if we look at the first one, 8 is the sum of 3 and 5. What are the buzzwords or phrases that we see in that? Avery, sorry. Is the buzzword for equals. Whoops. And what other buzzwords do we see in there, Hads? Sum. So one trick that you can do when you're writing these, when you find that buzzword that shows the equal sign, what you need to think about is anything that was before the equal sign is going to be on one side of it, and anything that comes after that buzzword or phrase is going to come after it. So 8 is means 8 equals. How do we write the sum of 3 and 5? 3 plus 5. Tough stuff. Here we go. 100 is as much as 5 $20 bills. Adam, what's the phrase or word for equals?
Is as much as.
Good. So this whole phrase is as much as. So here's where my equals is. What's my equation going to look like when I write that out, Lucas?
5 times $20.
Is one side. 5 times 20. What's on the other side?
Equal to 100.
Yep. 100 equals 5 times 20. Good. What about the next one? 32 is the same as the product of 2 and 16. Eva.
Product.
Good. Product is 1. What else? Yep. Is and actually. Good. Is the same as. So 32 is the same as 32 equals. What's on my other side?
2 times 16.
2 times 16. Very good. Let's try one more of these and then we're going to move on. Next one, 67 is equal to 33 plus 34. Calvin.
So the buzzword is like identical.
Yep. Is identical.
And so 67 equals 33 plus 34.
Good. 33 plus 34. Questions on that? Basically the same skill that we've already looked at. We just looked at it for expressions except for instead of equations. Okay, the other thing you're going to practice today is solving with substitution. Also something we did with expressions. We substituted values in and then solved, except now, because it's equations, once we substitute in and solve, we need to determine if the two sides are equal to each other. Okay, so for this first one, it says 15y equals 105 when y equals 7. So the first thing we should show is that I'm plugging 7 in for y, and then I'm going to solve here. So we need to figure out what 15 times 7 is, and if it is in fact equal to 105. Sammy? Are you sure, or are you just saying that because it says that it equals 105 up there?
No, it is.
It is. We've checked the math fact. All right, so 15 times 7 is 105. So we get a line that looks like this. 105 equals 105. Is that true? Yeah, so we say, yep, 7 is value for y. Okay? 105 is equal to 105. Next one is x over 8 equals 12. X equals 72. So we're going to plug 72 in for x. What does 72 over 8 mean? And what does it equal? Ames?
It equals 7.
Ooh, not 7.
Sorry.
What operation does the 72 over 8 mean?
72
Divided by 8, and that gives us what? 9. So we have 9 equals 12. Is that true? No. So all we have to do here is we simply put a slash mark through our equal sign. You probably remember that symbol from your pre-assessment. It's just saying is not equal to. 9 is not equal to 12. So that's showing that that value of 72 does not make this equation true. It is an inequality. Well, not technically, doesn't have the less than or greater than, but yes, they're not equal. All right, this last one that I have up here, 6 times b minus 10 equals 40. We're going to plug 15 in for b. What do you notice about this equation? What do you see here? Henson?
Distributive property.
Yeah, the distributive property. So you've got two choices here. You can either distribute and solve, or you can just solve it using order of operations. Again, using the distributive property is going to be a lot more effective and efficient when we've got variables in the mix. Now that we've made it all numbers, it actually makes a little bit more sense to just do order of operations and solve. So in the parentheses, we have 15 minus 10, which is 5. So we have 6 times 5 equals 40. What is 6 times 5? 30. Does 30 equal 40? No. So that's not equal. We could have also, if you wanted to, if you're somebody who's enjoying the distributive or wants to try more of it, you could have distributed and did 6 times 15, which is 90, minus 6 times 10, which is 60. 90 minus 60 is 30, and you could have solved it that way as well. Okay, so you're going to do a little bit of practice with these two skills that we just talked about. We've got about 10 minutes left. I think the worksheet has 12 questions on it. This is not homework, but I want you to see how many of these you can get done before you leave, and then we'll wrap this up on Monday. Okay, we're not moving around and working with people, but you are allowed to talk to the people around you just for time's sake here.